Hello, my amazing students. Today we're going to be covering a second day of scientific notation as well as some SBAC style practice. So let's actually get to it. What is important? Take a highlighter. I want you to highlight this zone right over here. This is the important stuff about scientific notation, that if you mess one of these things up, it will not be in the correct notation. So, let's read. Scientific notation. Are you following along? Scientific notation is a way of writing very large or very small numbers as decimals multiplied by powers of 10. The first factor must be between 1 and 10. That's very, very important. Put a check mark on that if you understand it. The second factor has a base of 10 with a positive or negative exponent, depending if the number is large, where it's positive, or small, if it's a negative exponent. The factors are separated by a multiplication sign. Let's actually write down an example. For the first example I want to write down for you, besides all these examples that we're going to be working on today, is going to be how far is the Earth from the moon? So in inches, the Earth on average is 15.1 billion inches away from Earth, or Earth is 15.1 billion inches away from the moon. So how would you write that in scientific notation? So I can't write down 15.1. That would not be a number between 1 and 10. Okay? So what would this be as a number between 1 and 10? It would be 1.51. Okay? Now how many zeros does a billion have? Well, it has a lot of them. I'm going to write down times 10, because that's a base of 10, to the power of 10, because it's this far away. I'm going to write down the number right now. That's how many inches it is away from Earth. So if you take that decimal, which is always secretly at the end of a number if there isn't a decimal already there, and you're going to count how many zeros does it take to get to 1.51. You're going to go 1, 2, 3, 4, 5, 6, which I love these commas, 9, and 10. So that's going to be scientific notation for this big number. Well, at least it's approximation. So before we do anything else, I wanted to go over an example. Here's some examples of scientific notation, and why is scientific notation so useful? Is because you can easily compare which numbers are bigger. Our first example is this one, and you can write this in your toolkit if you want to. 4.32 times 10 to the 7th, or 3.16 times 10 to the 7th. These are both very big numbers, but which one is bigger? As you can see, since the decimal is different, but the exponent is the same, it's very easy to tell which number is bigger. And yes, 4.32 times 10 to the 7th is much bigger than 3.16 times 10 to the 7th. Now right below that I have another example, and this is way more important, especially when it comes to the back side of your paper. Look at these decimals. They are different, but this one's clearly bigger. But if you look at the exponent, this one is going to be the one that is bigger. This means it's been multiplied by 10 one more time. So which one is bigger? Even though this decimal is smaller and this exponent is bigger, it means this entire group, which is written in scientific notation, is much bigger than this one. So let's get to it. Let's do a few examples. I'm going to try one, and I want you to try some on your own. Locate the decimal. where is the decimal? Let me zoom in really quick. There we are. The decimal is hidden somewhere here, and it's right there. So I'm going to locate where I want my decimal to be. I want it to be a number between 1 and 10. I want it to be over here. So I'm going to move over. How many decimal places? Let's see. 3, 6, 9, and oh, just like the Earth and the Moon, we have 3 point. Write everything after this. Write everything after the decimal we have here. 3.456. And instead of writing all those zeros, we're just going to write times 10 to the power of 10. Now, question for you. Which one is bigger? Kind of an easy question, right? Same power. This one's a bigger decimal, so this is further or bigger. All right, I want you to try out these two, and if you're really, really amazing, you're going to also work backwards from scientific notation and go to the number. You are amazing, so you can do it. I'm going to pause, and I want you to try these out for a few minutes. Go. All right, let's bring it back in 5, 4, 3, 2, and a 1. Hopefully I didn't count wrong. I counted 11 decimal places. Hopefully you got the same thing. If I made a mistake, let your teacher know. This one's 6 decimal places. It looks like it's right or correct. But this one's an interesting one, right? It has an 8 and no need to write 8.0 or anything. Your goal is to have a number between 1 and 10. Is 8 between 1 and 10? Yes. All right, let's go to the next one. So, for this one right here, I know I haven't shown it yet since perhaps last week, but let's make sure we know how to do it. So we're going to make sure to write down 2.379, and since I'm multiplying by 10 13 times, I must multiply by 10 once, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. 13 times. And what happens when you multiply by 10 so many times? Yeah, you're going to add a bunch of zeros. 3, 4, 5, 6, 7, 8. Looks like we need to add 10 or 8. I count wrong. 4, 5, 6, 7, 8. Yeah, looks like we're going to need to add 10 zeros there. Now, since the decimal is moved all the way to the end, we're just going to write this number as, well, let's start adding commas if you haven't done so already. Add the commas every 3 zeros, every 3 places, and it looks like the answer is 23 billion or 23 trillion, whatever number this is. That will be our answer. Okay, next up is number, well, the 5th one here, 5, and I need to multiply the decimal 10 to the 8th power, so 1, 2, 3, 4, 5, 6, 7, 8. Let me double check. 1, 2, 3, 4, 5, 6, 7, 8. Yep. Add all your zeros there, and the decimal is now at the end. Add your commas every 3 numbers, and it looks like this number is 500 million. Very good. And now the next one and last one that I had you do here was going to be 7.23. Nope, I got to write this down correctly. And I got to move this decimal over 3 places to the right. So 1, 2, 3. We'll make the decimal go here. And our number is 7,258.34. If you got all those correct, look at you being a legend. If you got at least one wrong as well, that's fine. Just make sure to ensure that your notes are complete. All right, we're going to go to Act 2. Act 1 was the basics of switching from back and forth between scientific notation and standard form. Act 2 is identifying errors. So, I want you to write something down. Our goal is to balance the scale. This is going to be one thing that I want you to focus on as we go through these problems. Keep in mind that if something is written wrong, we're going to need to adjust it not only on this side, but also this side with the exponent. So, what's wrong with this first one? Actually, I'm going to give you some time to figure this out on your own. Write down in words what was wrong with this, if there is anything wrong, and then I want you to fix the errors. Fixing the errors is something we haven't practiced a ton on yet, so try your best, mainly fill out this portion, and we'll come back and talk about it. All right, let's bring it back in 5, 4, 3, 2, and a 1. All right, so for the first one, I hope you had noticed that this is not a number between 1 and 10. So we're going to need to balance the scale. If I move the decimal to the left, I need that decimal to be right there. It will be 7.8539 times 10, but I need to change and balance the scale. So if this number gets smaller, this number has to get bigger. If this gets smaller, this has to get bigger. I'll say it again, let's balance the scale. If this number gets smaller by moving the decimal to the left, this number, the exponent, must get bigger. So instead of it being a 7, it's now an 8. Okay? All right, what's wrong with the second one? I'll put it in my own words. There is no base of 10. So the correct answer is 2.3823 times 10 to the how many zeros do we have here? It will be to the third power. So the 3 zeros means it's to the third power. Or 10 times 10 times 10 will give us 1,000. All right, let's go to the next one here. What's wrong with the third one? There is nothing wrong with the third one, so it is already correct. And finally, the last one here. The last one was also not a number between 1 and 10, so since we need to move the decimal to the right, which will make the number bigger, we're going to need to balance the scale. Since we make the number bigger, we're going to balance the scale by making the exponent smaller. So since it was an 8, it's now a 7. Okay, now's the time to ask any questions if you have any. All right, let's flip our paper, please. So Act 3 is going to be SBAC style practice. You're going to take some time to work with a partner, preferably alone at first, so work alone and then check with a partner to see if you have any similar answers or ideas. And as you work on this, I want you to remember what we did at the start. Which numbers are bigger? This one's bigger because it has a bigger decimal. But which one's bigger here? This one is bigger because it has a bigger exponent. So I want you to go ahead and answer these questions. The first one's about Asian capital cities and what their population is. So you're going to order it from least to greatest. And you're going to need to look at the population, which is written in scientific notation. So as you go, I recommend to put a little check mark on each one. Obviously starting with the smallest numbers first. So which one's the smallest? It's going to be the numbers with the smallest exponent. So this one, since it has a small exponent of 5, that has to be our smallest population. So please put Suva here. All right, now you go ahead and try all of Act 3 and we'll go over the answers in a few minutes. All right, legends, it's time to go over the answers. I'm going to just go ahead and show the answers slowly. Check your work for number 1, or letter A. It should have been Suva, Manila, Bangkok, Tokyo, and Beijing. For letter B, it's a good idea to rewrite the number. Actually, it requires you to there. So move your decimal over 5 places, 3 places, or 4 places, and see that the order should have been Jupiter, Saturn, Uranus, or I just say Uranus, Neptune, and Mars. Okay, good job if you got those right. Now for letter C, it should have been true, true, and false, because if you rewrite the number by moving over 2 decimal places, 3 decimal places, or 2 again, you'll find out that this will be the correct zone, and making these statements either true or false. So for the first one, it was true. It was in the sunlight zone. This one was true. It was in the midnight zone. And the last one was false because it should have been the sunlight zone. All right, legends. Have a great rest of your day. Work on your homework. And I'll see you next time.